Hey guys, I'm going to take you guys through a micro FRQ here, or actually three FRQs, a total FRQ from the 2016 year. Okay, kind of a strange year where they didn't start with a firm question as the first question. They started some stuff about markets, but made it a pretty difficult question actually. So anyway, let's jump right in here. Markets for bananas, muffins, and coffee are interrelated. Okay, so that means that um, they're either going to be substitutes or uh, complements to each other. Each market is perfectly competitive. All right. In the market for bananas, the equilibrium price is $1 per pound. The equilibrium quantity is 1,000 pounds per week. Suppose the government imposes a price floor on bananas. So price floor there, that means that the price cannot be below, you can't go below a floor on bananas at $1.20 per pound, causing the quantity supplied to increase to 1,500 pounds per week. Would the price floor result in a shortage, surplus, or neither? Explain. Okay, so not asking for a graph. So this could be a potential type of problem that you guys would see on this exam this year. But a sketching a quick graph for yourself is always going to help. So demand, supply, banana market. Here's your $1. Your price floor at $1.20. And the quantity supplied at 1,500 is greater than the quantity demanded. So that means we're going to have a surplus. And the explanation would just be simply is when there's a binding price floor, as is the case here, because $1.20 is greater than $1, there will be a surplus. There will be a greater quantity supplied than quantity demanded. Okay, the quantity supplied will exceed the quantity demanded. Okay, so again, didn't need to use the graph, but I would use the graph to help me understand what I'm looking at and just kind of double check. All right, calculate the price elasticity of supply. If the price increases from $1 to $1.20, show your work. Okay, let's go over here. If I remind you guys that price elasticity of supply is percent change quantity supplied over the percent change in price. If we're doing this quickly on an exam, I'm showing you guys how to do some percent changes before. Okay, so if you want to go back and watch that video, please do. But for right now, let's just run through this because if I look here, it went from 1,000 to 1,500 pounds per week. So that's an increase of 50%. And the price went from $1 to $1 per from $1 to $1.20. So that was an increase in 20%. Okay. Percents cancel, zeros cancel. I have 5 over 2, which is 2 1/2. Okay. So that's our answer to that. Okay, between $1 and $2 is the price. Supply elastic, unit elastic, or inelastic. Explain. And simply enough, it is elastic, and it's elastic because the price elasticity of supply is greater than 1. Okay, if it was 1, it would be unit elastic. If it was between 0 and 1, it would be inelastic. All right. Part B. So now we have this interrelated. So that was just purely about bananas, okay, and about price floors. So just kind of covering everything we've learned about a lot that we've learned about markets. Bananas are an input for muffins. Okay, so this is going to affect supply. Already I'm thinking, okay, supply. Bananas are an input for muffins. This will affect supply rather than demand. Okay. Draw a correctly labeled graph for the market of muffins indicating the equilibrium price and quantity P sub 0 and Q sub 0 respectively. All right, let's go ahead and do that. Simple graph. That's the thing is sometimes don't get too confused. It might be asking you a real simple question. Of course, you guys won't get to graph on this or won't have to graph on this exam. but you're going to, like I've said over and over and over again, you're going to have to know how to graph just to be comfortable with these questions. Done with that. Okay. On the graph drawn in part B1, show the impact of an increase in the price of bananas on the muffin market, uh, labeling the new equilibrium price and quantity P sub 1 and Q sub 1, respectively. Okay, so bananas are input for muffins. The price of bananas goes up. That's an increase in an input price, and that is one of our shifters of supply, meaning that supply will decrease because an increase in input prices causes supply to decrease, causing, as the graph will show us, an increase in the price level, or not the price level, in prices for muffins and a decrease in the quantity produced of muffins. Okay. On the same graph, completely shade the area that represents the change in consumer surplus caused by the increase in the price of bananas. Okay. So this one's a little more difficult. So originally, this area right in here was consumer surplus, but it's gone down into this little area right up here. So the change is this area right here. Okay. This area has been lopped off for consumer surplus. Okay. Simple enough. Because consumer surplus is any area, is the area below the demand curve and above the price. Okay. It's that triangular area. Okay. And again, it was the change. That's all we had to show. All right, C. In the market for coffee, the equilibrium price is $3 per cup. The equilibrium quantity is 100 cups per week. The cross price elasticity of coffee with respect to muffins is -2. Are coffee and muffins normal goods, inferior goods, and complementary goods, or substitute goods? Okay. So cross price elasticity, first of all, has to do with measures whether goods are how they're related to each other. So they measure whether goods are not related, whether they're substitutes, or whether they're complementary goods. It is income elasticity that tells us whether goods are normal goods or inferior goods. Okay. So this is only going to tell us if they're complementary or substitute goods. And since the cross price elasticity is negative, meaning that as the price of one good goes up, the quantity demanded for the other good goes down. So they are complementary goods. Okay. A positive price change is going to cause a negative impact on the amount consumed. Okay. So that makes it a complementary good. Okay. So people are consuming these together. Assume the supply for coffee is perfectly elastic. Using the equilibrium price and quantity given above, draw a correctly labeled graph for the coffee market and show the impact of an increase in the price of muffins on the coffee market. Okay. So still just a market question, just with one little strange kind of caveat to it. All right, quantity, price. This is for coffee. Okay, and the supply for coffee is perfectly elastic. Perfectly elastic supply is going to be horizontal. Not a very good horizontal curve, but draw this horizontally. Okay, that's the supply. The demand's still downward sloping. Didn't want us to label anything. Okay, and if the price of muffins goes up, it's a complementary good. So that's going to cause the demand for coffee to go down. Okay, because people like to consume muffins and coffee together. All right. Fine. Finally, given the original quantity of 100 cups of coffee per week, if the increase in the price of muffins is 10%, calculate the new equilibrium quantity in the coffee market showing your work. Okay. So this is where we're going to use our cross price elasticity equation to figure this out. So this is a percent change in quantity of coffee over the percent change in price of a muffin. Okay. That's going to equal -2. Okay. Yep. And so it says the price of muffins goes up by 10%. So let me substitute 10% in here. All right. Solving for the percent change in quantity of coffee, I multiplied 10% on both sides. And I get that the percent change in quantity of coffee is a decrease by 20%. A decrease by 20% of from 100 cups of coffee is 80 cups of coffee. Okay. All right. Terrific. And that's it for problem 1. So let's go ahead and check our answers real quick. All right. So number 1, 1 point is earned for saying the quantity supplied exceeds the quantity demanded at the price floor. The price floor would result in a surplus because the price floor is binding. Okay. 1 point is earned for correctly calculating the price elasticity of supply. There are several calculations you guys could have done. I just did this simple 50% over 20%, which gave us 2.5. So that would work. There's other things called like a midpoint formula if you're interested in it. And there's some other calculations here where they didn't use the percentages, just use the fractions, which we've done in the past as well. 1 point is earned for saying that the price elasticity that the price supply is elastic, and for explaining the percentage change in quantity supplied exceeds the percentage change in price, or because the price elasticity of supply is greater than 1. Okay. We explained that. There's our graph showing the change in the supply, the increase in price, the decrease in quantity, and also that shaded region showing our decrease in our consumer surplus. Here's our perfectly elastic supply with our decrease in demand. 1 point is earned for shifting it to the left, showing the decrease in the quantity and no change in the equilibrium price of coffee. 1 point is earned for using that equation and showing that our new quantity is 80. Okay, told you to show your work there. Terrific. So let's go ahead and move on to number 2. Okay, one of these tough total benefit problems. Okay. Martha has a fixed budget of $20. She spends it all on 2 goods, Y and X. Price of X is $4 per unit, and the price of Y is $2 per unit. Make a quick note of that. So X is $4, Y is $2. Okay. Martha receives from the table shows the total benefit that Martha receives from the consumption of each good. Okay, so this is total benefit, not marginal benefit for each. Okay, all right, great. Okay, what is Martha's marginal benefit of the 5th unit of good X? So it goes from $40 to $41 worth of benefit for Martha. So the answer there is $1. So real simple there. Trust me, it'll get a little more little worse off. Calculate the total consumer surplus if Martha consumes 5 units of good X. Show your work. Okay. Total consumer surplus. So she gets a benefit of $41. That's the total benefit. Minus, it's $4 per unit, so that's $20. So that's a surplus of $21. Okay. Okay. Martha is currently consuming 4 units of X and 2 units of 4. Use marginal analysis to explain why this combination is not optimal for Martha. Okay. So what you're going to have to do here is you're going to have to remember that we have this simple formula: marginal utility of X over price of X needs to equal marginal utility of Y equals price of Y. Okay. Um, so if we look at 4 units of X, that is 40 divided by 4, which is 10. Okay. And then she has 2 units of Y, which is 18. 18 divided by 2 is 6. So 10 is greater than 6. So she would need to increase the amount that she consumes of X while she decreases the amount of Y. Okay. All right. So that leads us to this problem right here. Um, what is Martha's optimal combination of good X and Y? So what we're going to do is we're going to find all these marginal utilities per unit and see where they're equal to each other and see if that is with our um, budget constraint. Okay, so for this one, it's 0. For 16 divided by 4, that'd be 4. 28 divided by 4, that would be 7. 36 divided by 4 is 9. 40 divided by 4 is 10. And then 41 divided by 4 is a little more than 10. Guess what? 10.25. Okay. 0, 5, because we're dividing by 2, 6, 12, 14, and 15. Okay, so if I'm looking for places where they are equal, a place where they would be equal with the marginal utility per unit, it would be somewhere between, let's see, this 6 and 7. Oh, you know what, guys? I just messed something up too. I took it out of the total utility. We're going to have to do a little more math. That's why it did not look, that's why it looked funny to me. I'm so sorry. Okay, so this is 16. 16 divided by 4 is 4. Okay. Next one is 12 because 28 minus 16 is 12. Divided by 4 is 3. Uh, yeah. This is 8. That's the marginal utility. Again, I have to do marginal utility, you guys. Gosh, that means I did the other one wrong too, but we'll go back to that one. Sorry. I've been using total benefit when I should have been using marginal benefit. This is 4, so that's going to be 1. And this is 1, so that's going to be 1/4 versus 10 divided by 2 is 5. This is 8 divided by 2 is 4. This is 6 divided by 2 is 3. This is 4 divided by 2 is 2. And then this is 2 divided by 2 is 1. Okay, so what I've done is I've found my marginal utilities, and then I found my marginal utility per price. Okay, and our marginal utility per price is what's going to tell us what are some optimal combinations. So let me redo number. I'm going to redo number D, where it says consuming 4. So the marginal utility of consuming 4 was 4 over 4, which as we can see is 1, versus the marginal utility per price of 2 units is 4 divided by 2, which is 2. Again, you can see that it's suboptimal. The only difference here is that it's showing us that you want to uh, decrease the amount that you're consuming of Y and increase the amount that you're consuming of X. Okay. It's just a little flipped around there. Okay. So let's look at some optimal combinations here and see what makes sense. So this 4 is equivalent to this right here. Okay. So she can consume 1x and 2y. The only problem with that is it doesn't get you to 20. Okay. It doesn't get you to 20 because 2 times 2 is 4. 4 times 1 is 4. So she'd only be spending $8, which is suboptimal because she wants to spend all her money. Okay. Let's go down here to 4. And that's 1. And that would be 5. 5 times 2 is 10. 4 times 2 is 20. That's too much. Okay. It's going to cost us too much money. All right. So then let's look at. All right. So the next would be 2 and 2. So the third unit here is 2. And this fourth unit is also 2. 3 times 4 is 12. 4 times 2 is 8. That equals $20. So there's your answer. 3 units of X and 4 units of Y. Okay. Indicate whether each of the following will cause the optimal quantity of good Y to increase, decrease, or stay the same. The price of good Y doubles. Okay. So the price of good Y doubles, then you have to cut all of these marginal utility per prices by half. So that would actually go down, okay? Because this would be, this 2 would change to 1, and 1 would change to 1/2, or I mean, 3 would change to 1/2, and 2 to 2. So it would actually go down. Martha's income falls to $10 with no changes in prices. That's going to cause good Y to decrease as well, okay? Because we got a bigger budget constraint. Martha's income doubles, and the price of both goods double. Okay, uh, I'm going to say that. Okay, I'm going to say that in this case, everything would stay the same because both prices doubled. The marginal utility per price would go down, but then she could also double her consumption. Okay, so let's go ahead and check these answers real quick. Again, sorry for that little snafu with the marginal utility part of that. All right, so the 1 point for marginal benefit is $1. We got that. The $21 is fine. 1 point is explain the combination is not optimal because uh, we got 4. Is that what I did? Was it 1? Yep, 1 is less than 2. $8 per $2. Okay. Marginal benefit or marginal price. Okay. So just showing that it's not equal. Where did they get 4? Where did I get 2 versus 4? 2 units of Y. That's 4. Oh, because I shouldn't have divided this by 2. I'm sorry, guys. So this was actually 8 divided by 2. I'd already done the math, so that'd be 4. Okay. Same result though. Yeah, so this was marginal utility is 8 divided by that's the 4 right there. Okay. Anyway, 1 point. So we figured out it was 3 of X and 4 of Y. Quantity of Y would decrease with the price changes, and then stay the same if both doubled and her income doubled. Okay, perfect. All right, let's go on to number 3. All right, Camden's Cakery is one of the many dessert cafes serving a local community. Each cafe produces a slightly differentiated product, but there are no barriers to entry and exit, and the firm is in long run equilibrium. A lot of information in that sentence. We're hearing uh, there's many firms, no barriers to entry, uh, and it's a differentiated product. Trifecta there. We know for a fact that we have got monopolistic competition. It says the firm is in long run equilibrium. Well, as we know, if a firm is in monopolistic competition and is in long run equilibrium, it is earning zero economic profit. Okay. So it says draw a correctly labeled graph showing Camden's demand curve, marginal revenue curve, marginal cost curve, and long run average total cost curve. Label Camden's profit maximizing output Q sub M and P sub M. So this test this year didn't start with a firm question, but it made sure to put one in there. Okay. So we got this quantity, price, downward sloping demand, downward sloping marginal revenue. Okay. This is the monopoly side of the monopolistic competition because it looks just like a monopolist firm's graph. Our profit maximizing quantity, just like a monopoly, is found, or actually just like any firm, is where marginal revenue equals marginal cost. Oh, I better call this marginal cost before I get in trouble there. Just like a monopoly, though, we go up to our firm's individual demand curve, find the price right there, and that's P sub M. Okay. Unlike a monopoly, too, if we're in long run equilibrium with a monopolistic competition, we're going to have zero economic profit because there's zero barriers to entry. That means price is going to equal ATC. So I got to make sure I draw an ATC curve that touches that. And then, of course, the ATC has to minimize right there at the marginal cost curve, but it must touch right at the price on the demand curve to show that we are earning zero economic profit. Or I guess it could go through the demand curve in some way, just as long as you draw out where the price equals the ATC at this quantity Q sub M, and also make sure that ATC is right at the bottom at the marginal cost curve. Okay. Minimizes the marginal cost curve. On your graph, label the output at which total revenue is maximized, Q sub R. Love this, okay? Again, total revenue is maximized right here at Q sub R, okay? Where marginal revenue equals zero. That's where marginal revenue is maximized. Okay, let me quickly do this so the computer doesn't die. Do firms in this market experience economies of scale, diseconomies of scale, or neither in the long run equilibrium? Explain. They're experiencing economies of scale, and simply put, it's because we're on this side. We're on the downward sloping side of ATC. Okay, that's where there's economies of scale or increasing returns to scale. If we're on this rightward upward slope of ATC, it would be diseconomies of scale. Let's check these answers real quick. Real simple. Okay, looks just like my graph. Q sub R has to be where MR equals zero. And 1 point is earned for saying that firms in the market experiencing economies of scale in the long run is decreasing, or Q sub is in the left of the minimum point of the long run ATC curve. All right, thanks for your attention.